All right, Algebra 1 OST review on topic 8 quadratic functions. Huge section here, quadratics, right? So first of all, let's talk about the generic quadratic function f of x equals x squared, right? So it's a parabola that opens up. This vertex right here, okay, if it opens up, it's going to be called a minimum, okay, because it's the lowest point. If for some reason your vertex, if your parabola opens down, now your vertex is called a maximum, right? And what we're talking about here, we're talking about the y value, right? It's the y value that is the minimum or the maximum. You have an axis of symmetry that goes right down through the middle of your parabola. It separates the left side from the right side. It's a mirror, right? That's why we call it symmetry. Okay? All right. Now, if you throw an a value in front of that, x squared, it's going to control two things. So first of all, it controls direction, up or down. If your a is greater than 0, you open up. If your a is less than 0, you open down. So positive, negative. If your a is greater than 1, you're going to be wide. Oh, I'm sorry. If your a is greater than 1, you get narrower. I'm sorry. So what happens is your parabola opens up faster, skinnier. If your a value is in between 0 and 1, right, then you're going to get wider. Because you're only going up half as much, you're not going up any faster. Okay? So that's all described down here. Okay. When we talk about increasing or decreasing, right? So if we start on the far left and we go towards the vertex, notice that I'm going down. So as I go from left to right with my x, my y's are going down. That means we're decreasing. And we're decreasing when x is less than 0, right? The vertex is when x is 0. The left side of that graph is when x is less than 0. If we do the right side, starting at the vertex and going to the right, now we're going up. So as I'm still going up, or to the right, my y is now going up. That means I'm increasing. And that would be when x is greater than 0, the right-hand side. So again, your intervals are based off of the x values, but it's how the y is changing. Is the y going up or going down? Very, very, very important stuff there on the characteristics of a quadratic. Vertex form. Again, very important form. This is not given to you on the state test. You should know this, right? So again, in vertex form, the vertex is the point h and k. Remember that this h has a minus sign, but it comes out as opposite. So you always make the h opposite of what it says, and then the k is the same. The axis of symmetry goes through the vertex, so it has the same x value as the vertex does. Okay? So for instance, right here, you have a vertex of 1, 3, opposite of negative 1, and then same as 3. So there's 1, 3. That negative 2 makes it open down. And again, your axis of symmetry would have an equation, x equals 1, matching the x of your vertex. And again, you can always just use Desmos to graph the picture to identify the vertex. It'll graph it for you, and you can just hover, and it'll tell you what that vertex is, what the h and k are. Standard form for a quadratic, very important, right? It always has to say ax squared plus bx equals c, right? If you want to find the y-intercept, the x terms would go away, c is your y-intercept, right? So there's your y-intercept. To find the axis of symmetry, there's this clever little thing. I don't think you need to know it. I think that if you just graph it and able to identify the vertex, you'll be fine. So I would not cloud your mind with this opposite of b over 2a. So again, just use Desmos. Okay, if we take a look at the modeling, so again, just remember area is a very good application of quadratics because you can multiply. When you multiply 3x times x, you get 3x squared, quadratic. They'll give you this form if you need it. We're not going to do residuals. And then down here, when we talk about the different models, right? So we're going to do regressions, right? So if you get a table of values, right? A table of values, we're going to skip exponential. Table of values. Plug it in to Desmos. And then for your linear, y1 squiggle, ax1 plus b. For your quadratic, y1 squiggle, ax1 squared. So remember, you have to put the 1 down here and the squared, plus bx1 plus c. And again, you'll get those two. And you should be able to look at your data and see what you think it's going to be. But that's your regressions. So from this lesson or from this topic, formulas that I would try to remember right? So first off, I would remember vertex form. F of x equals ax minus h squared plus k. I would remember standard form. F of x equals ax squared plus bx plus c. And then your quadratic regression. Y1 squiggle, ax1 squared plus bx1 plus c. That's what I would remember from the quadratic. Topic 8. All right, very good.